Welcome to the IAM in the Cloud talk. And just to give a brief introduction to who I am and what I do, my name is Ochaun Marshall. I code, I teach, I hack. I work for Security as a full-time developer as well as a full-time security consultant. And when I'm not doing either of those things, I'm teaching you the wonders and insights I gain along the way. Basically, I spend a lot of time bashing my head against the keyboard in one domain or the other. This talk is going to be focused more on the sort of builder defender type. But even in this sort of talk, we still carry around that professionally evil ethos. And part of that is just understanding how things work. Because if you're going to attack it, if you're going to get on the offensive, you actually have to understand IAM in how it works if you're going to apply that knowledge. This talk is more geared towards people who spend way too much time staring at the console and trying to figure out, okay, now how would I get this working, first of all? And then after that, how do I then make it secure? So I was inspired by the recent footage of the Olympics. So the agenda for today is going to start at a crawl. So we're just going to go over basic definitions and terms of what is a policy, what is IAM, all of that. And then we're going to do like the triathlon thing where we're just going to, all right, now we're swimming and now we're just hopping on the bike, and then we're hitting the laps on the track. That's how this talk is sort of designed. So we're going to introduce on the basics of the cloud security problem, then cover IAM resource policies, and then go into STS. And the reason why we would want to cover that is especially because cross-account access is really important. And then we go to service control policies. I could not fit the trusted advisor or the IAM access analyzer. Just ping me. I could actually think I can throw a blog link into the chat. Yeah, that was my review of Access Analyzer. It's a really good tool. It's free. You can enable it and you can manage cross-account access. So a real freebie right off the bat. And then towards the end, we'll talk about how it all fits together. So, and it won't seem too much like that, like Charlie Sheen pointing at the diagram meme. So there are some things that we won't cover because I only have you for an hour, and that is VPC endpoints and federated identities and OpenID, those sorts of use cases. You can find them in AWS documentation. And I couldn't fit like the basic entry level stuff along with that into this talk. And if you're more interested in general purpose AWS security controls in addition to IAM, then see our previous webinar, 9 critical security controls you should be using in AWS. Jason and Eric did a wonderful job on that one. They introduced, the first thing is develop an IAM strategy. That's what we're going to spend a whole hour talking about. The tools of the trade in which you can develop your sort of IAM policy strategy. And there you can check out the other 8. So here is the cloud security problem. And you or someone in your organization thought it would be awesome to soar into the clouds. And what you find is that once you sign up and like create your account, you've got all these services, all these many different pieces and tools that fit together in unique ways and that have their own idiosyncrasies. And most of the time, we're spending time just slapping it together to make it work. And making it work is wonderful. Making it work makes makes people money. It keeps businesses afloat. And that's like where you have to begin. That's the first level of, understanding IAM is, just sort of fitting together policies and getting an intuition for it. But that cannot be the only steps. So yes, these three steps will just work. It was probably the sort of demos that came out when S3 was one of the first services AWS released back when it launched. So the Medium articles and the demos, they used to always do things like this. At least now you get like a disclaimer like, hey, you've got to provision this policy down and make it more granular. But yeah, this is how you would get, for example, an EC2 instance to talk to an S3 bucket. And it's wonderful. It's easy. It's great for a POC in the demo, but it's terrible for security and you will be breached. So it's not, this talk isn't necessarily about a security talk. It's an engineering talk, and it's about how to build effectively. And so in order to understand in order to understand how to build better, you need to understand the material that you're working with, as well as the tools that you have to trade. And this is where we come in. So this slide was adapted from some other talks that I've given. The bucket is S3 buckets are kind of a red herring, but that's how you hook people in. It's like, oh, S3 buckets are vulnerable. They're only vulnerable if you open them out to the world. And so in order to understand what I mean by overly permissive access, you need to understand that what I mean by IAM policy, I'm referring to two sort of distinct things. You'll see in AWS documentation where it's referenced as a permission policy versus a resource policy. And you will probably need to use both. All the best accounts do both. You'll see flame wars and people online trying to convince you to one camp or the other. It's just like, only use IAM. Well, IAM you can use only IAM, and you can use only resource policies for a specific resource. For if your account only deals with things like S3 buckets, but typically you're going to have to use both, so you're going to have to understand both. So the first system on the left is IAM, and that works with users and entities acting on a user's behalf. And the second system is resource policies. These are things that are like resource-centric, like S3 bucket policies. But we will see that you will find resource-type policies even nested in IAM. But just to keep things simple for now, we're going to start with an example. I'm a developer, and then as a developer, I have access to the company source code. And as a consultant, I can also create a server for cracking passwords. So that refers to my roles as a particular users. So also AWS services can have permissions and be granted access. Because the default, as you'll see later on when we discuss, is that nothing works, nothing talks to anybody, and you have to use the root user for everything. That is the default. And so IAM is learning to open up access in the right way to get things talking to each other. Our higher level standard after just getting communication is then applying that principle of least privilege. So let's say you're using Code Pipeline to deploy some web app. You have your source code in GitHub, and Code Pipeline is an AWS entity, is an AWS service that has a role as well. And that would need within its role, it would need a policy that states, hey, I'm allowed to access this S3 bucket or pull code from GitHub. And that's an overly simplified, but that's the sort of basic of IAM permissions policies. They're just JSON statements. And then you have S3 policies. This is a bucket with its own locks. You can specify at the level of the resource, at the level of the S3 bucket, what conditions or under what parameters are you allowed to access it, and what can you do with it. You can make it so that only certain IP addresses can access the bucket. You can lock it down with MFA, and it really depends on your use case. And most people, what people can do is they can use S3 buckets for like payroll data, and you can also, which is something that's really confidential, and you can also use it to store a static website that you intend to be open to the world. So messing up in either will be painful. So now that we've got like the diagram, policy is just JSON. Roles, users, and groups are containers for different policies. So you can do an inline policy for a user, like for example, just go to a user, just throw in the JSON or policy, and that would work for like 5 or 6 users. And then you will find out that as your environment grows in complexity, you will need to centralize it in its own customer managed policy, meaning that's something that you write, but you reuse that policy for multiple roles, users, or groups. Now, this is what the JSON is looking at for IAM policies in general, for permissions as well as resources. Remember the PARC acronym. Here, your job as a consumer, as a user of AWS, your job is to specify what IAM principles, which is sort of like the subject, what actions they're allowed to perform on specific AWS resources and under which conditions. Think of it like PARC. And you will see some similarities if you look at these two side by side, because the only difference between IAM policies and resource policies is resource policies, they have to be explicit and they have to mention a principle. Whereas an IAM policy, you assume that this is attached to a user, a group, or a role. And so there, the principle is there originally, but it's implied. If you attach the policy on the left to a user or user group or role, then that is the principle for this policy. So it's the same on the left and the right. And once you realize these two things are one, it's just mind blown. So we've gone to what is our job and what is our responsibility. What is AWS's responsibility in terms of IAM and identity management? Well, on AWS's side, they have to field incoming requests, and from there, they have to evaluate if access is to be allowed or denied. And this is the flowchart we can use to talk about policy evaluations. So the default option is set to deny. That is the default decision. When an AWS spokesperson goes on the news after a breach and says, oh, it's secure by default, they are absolutely right. The starting state is deny all access. And that's the original state. Nothing talks to each other. Nothing connects. So Then you have the processing step where you evaluate all the relevant policies. And so there's some magic and there's some black box in there, but the goal is to pull up what's relevant to the current principal based on what request came in. Is there an explicit deny statement? So that's step 3. And traditional flow chart, the left is the true case and the right is the false case. So if there's a deny statement, then we will deny. And this is this is the deny case, which is the explicit deny case. And those censor bars are not a typo. That's standing for cursing, which is one thing that one time where a deny statement screwed me over. And quick story time on that. I was working with some S3 bucket policies that were custom for an ongoing development project that we have internally. And just to mess with access, actually set the principal to star and S3 action as S3 : star, as well as for this specific resource for some bucket that I was working on. And I kid you not, I knew something went wrong when, in the console, they have ACL's description and the sort of access level. And there, the access level was error. And it was just red text all the way down. By applying that overly expressive deny statement, I actually locked myself out of the S3 bucket, and I wasn't able to do anything with it. I couldn't apply new ACLs. I couldn't even look at the files within the bucket. It just became absolutely blacked out for me. If you ever discover yourself in that same situation, the only way pretty much is to get the root user to remove the deny star ACL, and then that opens up access again to users and things within the account. So an explicit deny takes precedence over any allow, and that's something that you need to understand. So, all right, so there's no deny. So let's say that there's no explicit deny statement. Now we're going to check, is there an allow statement? If that's true, then allow. All it is just matching JSON. That's all IAM is. However, if there is not an allow statement, you have the default deny or the implicit deny. And that was the same condition where we started. So hopefully you can guys got an understanding. That's how that's AWS's responsibility, is to evaluate incoming requests and then assess them based on the current policies that are in the account. Our responsibilities as administrators and owners of AWS accounts is to define who can do what and under what conditions. And so, troubleshooting permissions in the console is going to be a hassle. I'm not going to lie to you. Secure use of the platform, and then generating principle of least privilege is going to be tedious and requires a lot of trial and error. This is not something it's not something easy where you can hand off an already built project to the security team and then just, all right, go lock it down. It's something that needs to be tackled as you're building the project. And when you have dozens of AWS services interacting with each other, these sorts of troubleshooting gets exponentially more difficult. So what's the solution? So what can we do instead? And one of the tools that two of the tools that I present to you today that's really useful is the AWS Policy Generator. So if you're uncomfortable with JSON, which is just curly brackets, quotes, and commas, but if you're uncomfortable writing, you hate it, you miss a comma or miss a quote somewhere, and it just frustrates you, there's the policy generator that helps you write IAM policies, and then there's the policy simulator that allows you to troubleshoot and test. 90% of your use cases will be covered with the policy simulator. Usually, in context, is if you have to troubleshoot permissions, it's just matching. I will give you one exception, and of course that one exception is S3. And one time that I was doing it, I spent 4 days on this. I kept getting an S3 access denied, even though I had an IAM policy that worked, and I also had an S3 bucket policy that matched. That also worked. The problem was, and this was highly contextual, I was creating a CloudFormation template for an entire code pipeline. And so I had to use custom KMS. I actually spun up a resource for a custom KMS key. So because one of the service roles in my nested project did not have access to the KMS keys to decrypt objects within the bucket, S3 bucket, that was an access denied. Now, that's a gotcha that happens all the time as things get verbose and complex. But in the beginning, when you're first setting things up, as well as basic how-tos while you're building your project, the policy simulator covers 90% of your use cases, because most of the time, it's not those gotchas. Most of the time, it was you applied the wrong action, or you specified the wrong principle or the wrong resource in the IAM policy. All right, so now we jump over to a permissions boundary. And this is a bit more advanced, so we're picking up the pace here. Permissions boundaries are for when you as the administrator can trust your users to set up IAM roles. So all you needed in order to secure your AWS account, honestly, you can just use IAM policies and then just set them and continue on that way. What you will find is that as you work with teams of cloud practitioners, devs, sysadmins, there are many people within your organization who actually can know how to create IAM roles, and that's just part of building or doing something in AWS. So if you need to trust your users to set IAM role, to do things like set IAM roles or do certain actions, but you don't want to trust them too much, that's what a permissions boundary is for. So what a permissions boundary is permission boundary sets the maximum amount of permissions a user can get, and that is evaluated along with the IAM permissions policy. So the effective permissions, the only effective permissions that they can do is a union of what is allowed in the permissions boundary, as well as what is allowed as part of an IAM for their IAM permissions. So they only can do everything within the golden center. And we can give you some examples to hop into the JSON. So a permission on the left is a permissions boundary, and the permissions boundary allows like full access to S3, full access to CloudWatch, and full access to EC2, and restricts it to only those services. Now, A permissions policy here in permissions policy is what the user or group will actually work. And here we say we have a put object S3, meaning write a file. In simpler terms, write a file and upload it to S3 into a specific bucket called some bucket. Now, with these two in mind, the only thing that the user will be able to do with this permissions boundary is put objects into that bucket. That's because, remember, it's the golden center. A permissions boundary prevents overly permissive access to grow. So this user could say you could put admin on the right side, like administrative access on the right-hand side for the permissions policy. It's not going to go through and it's not going to set because the permissions boundary specifies the maximum permissions are S3 access to S3, CloudWatch, and EC2. So permissions boundaries, you could trust your users, but you can't, but it helps rein them in so you don't have to trust them too much to the point where they can escalate privileges. Now we go to the simple token service, STS. And so the benefit of STS is that the credentials are temporary, limited privilege for IAM users or service roles. And so you don't have to distribute or embed long-term AWS security credentials within an application. And you can provide access to resource without having to define an identity for them. That's the access without identity part. And so the image is actually pretty relevant. This is the sort of thing that you will get using STS as a session token. And these things are auto-rotating, meaning that these are temporary security credentials that have a limited lifetime. So you don't have to rotate them. You don't have to explicitly revoke them when they're no longer needed. After the temporary credentials expire, they can't be reused. And I'll cite an example of a service that uses STS by default, and that's Cloud9. And so AWS offers a fully fleshed out IDE environment within its EC2 offerings called Cloud9. And I spent a lot of time working and developing there. I didn't really have to worry about setting up the AWS CLI or the profiles or whatever for the most part, because the Cloud9 instance just ran with the credentials I was using as a console user. So the Cloud9 instance that I was connecting to was able to query and make AWS calls as if I was doing it from the console or any other EC2 instance for that matter. And so, and for the credentials for those auto rotate. And so that's already scripted out and provisioned. So on regular intervals, like maybe even a day or so, the session tokens would automatically refresh and circulate. So on the machine, even if the credentials on the machine were compromised, on the Cloud9 instance were compromised, if an attacker didn't capitalize on them, those credentials would have expired anyway, and then the access would be revoked. And so why do we cover about STS? Why talk about STS when we're developing an IAM cloud strategy? Well, STS is really good at provisioning temporary access, rotating it without having to create an identity. Those feature sets are really useful for cross-account access. So let's say you have a master account A, and then you have a developer sandbox B. You want A to be able to assume a role into B. In this case, this is going to be an administrative role in B, and this is like the tech lead, and this is someone who has to set up permissions in that separate account for developers. And so we'll call them dev admin. And in order for this to work, there needs to be a trust handshake. So in order for A to assume a role into B, because remember, the default is deny. So you have to have a trust handshake in order for A to be able to assume a role in B. B has to set A as a trusted entity. Now you will see this as an option in the console when you try to set cross-account access. But if we're trying to do a deep dive here and dive in the nitty-gritty, so we're going to go through and show the different cross-account access. So here is the cross-account access. The account A has an IAM policy. This is STS assume role. That's going to be the action in the simple token service and then assume a role, and this role is in whatever the dev sandbox account. The role is called dev admin. In order for this to work from account A side, the account B needs to be able to needs to have this trust policy. No, it's not an IAM policy. It's not a permissions policy. We haven't even discussed what permissions this role has. The trust policy needs to be applied. And you will notice that this is awfully familiar. And let's see the laser pointer tool. You will see that right here, there's the principle involved. So this is a type of resource policy. So here is that example diving in from way in the beginning about what where resource policies are used in IAM. So here, the trust policy has to be applied saying, all right, in prod account, the root user in prod needs to be able to have access to this action, be able to assume this role. However, Park, in this case, we would want this sort of connection to be secure. So we would enforce multi-factor authentication. And so that can be easy. This is a console option, is really easy, but other conditions like IP address and time as well, those are conditions that you can be set, and those are just, again, key value pairs. And so all the types of conditions you can find, there's an AWS documentation page that I go to constantly because there are 212 AWS services. Don't quote me on that. That might be since 2019 or early 2020. So there are constantly new services coming out, and there are over 4,000 actions, 4,000 plus actions. And so that documentation page, resource actions, resources, and keys, those that documentation page will be helpful for you. Ping me, whether it's through Slack or harass me on Twitter. I will find that link and give it to you. And now we go into AWS Organizations. So AWS Organizations, here you manage multiple AWS accounts. And the goal and the use case of what we're going to talk about later, which is SCP, that is, all right, we're setting guardrails to an account. This is a situation not where you're governing account just by simply assuming rules. This is where you've got an AWS organization set up and you're actually have a master AWS account and then a sub organization account. That is a full separate AWS account. And rather than just doing cross-account access just by assuming rules, here you're applying some governance at a more global level. So here, what's really powerful about SCP is that it sets guardrails to block services. So if you really want to ensure that this AWS account doesn't try the newest gaming services, you can explicitly block it. And you can also set up an SCP with service control policy to sort of whitelist and only allow certain services. My only suggestion against that is because in practice, you will find that there are secondary and tertiary AWS services that are closely tied to other services. And so you may break things here. Best thing would be just to probably blacklist and keep that up to date as new services develop. So now we jump into SCP, and it's not that kind of SCP. No one into collaborative online horror fiction? No? All right, so SCP here is not something big or scary. It is guardrail. So here we've got what looks like a permissions policy, but the difference is that this policy will be evaluated before any resource or any IAM policies. So at this level, our use case here is developers can't make you users, can't stop CloudTrail, remember repudiation, stride, and or use AWS directory service. So SCPs cannot grant access. So the best thing to do here is just keep the default SCP, which is within every AWS account, and that is *allow. That doesn't allow every account or every user or every entity within an account to access every service. What it does is just opens things up so you can use the account. So the best way to limit permissions here is have an SCP that says, all right, explicit deny statements over these services, these actions, and in case of the directory service, the entire directory service. And so if you apply this in AWS organizations at the service control policy level, here doesn't matter what IAM policy it is, doesn't matter what resource policies are applied, it will be denied. And so we covered a lot of different stuff. So we've covered service control policies, IAM policies, and resource-based policies. And I'm going to share with you a diagram that I pulled shamelessly for becoming an AWS IAM policy master in 60 minutes. If you want links to that talk, again, harass me. I'll send it to you. It was a good talk and inspired me for this. This diagram shows how each of the different policies and each of the different fit together. Remember the flow chart from before. it's still the same process. In this case, we're stepping into that. Here is all the different places we look for allows and explicit denies. So on the service control policy, if we had the same service control policy here, you have to have, in order to use any resource, you would have to have a service control policy that allows it, and you would have to have an IAM policy or a resource-based policy. If you're using permissions boundary, it has to be allowed within the permissions boundary and the permission policy and the scope down policy if you're using one. We didn't cover scope down policies, but they're a way of templating in different entities in your IAM policies. So we're focusing on the first two. So if we have a service control policy, that's the default, which means allow everything. And we have a permissions boundary that allows a specific action. So S3 put object, and we did not set a specific resource-based policy. The condition there is to allow. And the reason why that is allow is here is that we have an IAM policy here that says, all right, we're allowed to put object on a specific bucket. Now, if we have an SCP that explicitly denies S3, so explicitly denies S3, it does not matter what permissions boundary or what permission policy is set within the environment, it's a deny. And for SCPs after a certain date in 2017, it for accounts in after 2017, it applies even to the root user. That's how powerful SCPs are. So if you want to make absolutely sure that on a global level, certain actions and services are not to take place in certain accounts, the best way to do it is as part of AWS Organizations, and then just set the SCP from the global master account into the sub accounts. All right. So for cross-account access, so let's say SCP, it allows it. We didn't really specify anything in IAM, but for the resource-based policy, we allow access. So put object, get object, that sort of thing under the resource policy from the bucket, and then specify as the principal the account. From there, that's going to be an allow, because the resource-based policy, you can specify an ARN. You could specify the ARN, and the service control policy does not explicitly deny it. And so, yeah, that's sort of how policies work together. It's just the precedence and sort of order of operations. So this is a quick recap. So here we solved part of the problem with CloudSec. And then part of the problem with CloudSec is you've got a handful of tools, handful of material, but it's not really, there's no like manual. There's, other than the AWS documentation, there's no like sort of piece together, all right, this is how things work. That in order to build things securely from the get-go, you have to understand how IAM works in AWS. And you need to understand that IAM policies, which are two types, both permissions and resource policies, follow PARC. There are principals who do certain actions on specific resources under certain conditions. So even if you don't have to specify a principal for a permissions policy, for example, there's still that park model. The principal in that case is just the entity where you have attached that policy to. Everything is denied by default, and the best way to troubleshoot IAM is to start with the IAM policy simulator, and then from then on, try it out through the console. Then you can do permissions boundaries, and the goal for a permissions boundary is to limit privilege escalation from within the account. The STS is really useful for temporary credentials from within the account and is especially useful for cross-account access. And for AWS Organizations, you've got service control policies known as SCP. And from there, in this global space, that's how you can administer from one AWS account and lock down specific services that no one within that account can use. And that applies not just to all users, but even to the root user itself. And that covers it. So, any questions?